welcome. And today we're gonna start with the first episode of the ultralight chassis design for the skateboard, as I mentioned in my introduction video regarding the skateboard. What you'll see here is the vehicle that I already showed and the basic layout of my interpretation of what a skateboard design could look like in an affordable design. What I'm going to start with here, you can see the chassis, and this chassis has not been designed in the first go. It's something I've been designing in several different stages, and I've done calculations to see what the strength is in the front crash, in the side crash, in a rollover, in a rear crash, and it all determined a certain design for the chassis. And based on that design, this is basically what came out. The thing now actually is to make it even more light, because my aim is to go under 70 kilograms for the base chassis, and at this point we're almost at 80 kilograms, and my ideal target would be around 60 kilograms. The first thing that we are going to do is design the lower frame rail. This is basically the backbone of the chassis, and since it's quite a large profile compared to the rest, we can direct our large forces towards this beam. And this beam needs to be lightweight, and one of the things that I want to do is design everything so it can be laser cut. And one of the big advantages of laser cutting these days is actually that you do not have to make separate parts anymore. If you design your cuts well, you can actually make this bended part that I showed you out of one piece by making pie cuts, and then you can just fold it over and weld it. First of all, you don't have to align it anymore because it's already aligned and it only fits one way. You only have to weld 3 sides instead of 4, and basically with a very simplistic mold or jig, you can basically make a frame rail like this. First of all, as you can see, I've made the pie cuts, and secondly, I'm making a lot of big holes into the chassis to reduce the weight. And that's basically the starting point for this project. Now the next bit is the tricky bit. I need to tell you that I've tried this several times over, and I had to experiment with this because it's very difficult. But what I wanted to do is I want to have a configuration where the part is straight, basically how it comes out of the laser cutter, and then I want to add a configuration where the part is actually bent up in a way that it should be. After welding, basically. Now there are some ways you can do this, but most of them, or at least the ones that I could find, were either for one bend, or they required you to make separate files. So you would have one file where your product is straight, and you would have a secondary file where your product is bent. And this is something I did not want, and as you can see from the lower frame rail, it has several bends in several different directions. So this posed a challenge, and it was very difficult, but I finally managed it to get it into a very close range of what it needed to be. I believe there is 0.1 degree deviation in some part somewhere, but it's good enough for me where I can use it. Now let's go back to what is happening on the screen at this point in time. As you can see, I'm making all the holes in the chassis rail so that it will become more lightweight. And next thing that I will be doing is that I'm going to make all these small holes that are just one or two or sometimes a little bit more tenths bigger than the actual thickness of the profile. And what are these holes are for aligning another tube. So basically what is happening is that at the front here I'm gonna insert a tube, and that tube has four small fingers at the end, which I can slide into this tube. And on the other side it's the same. So when I fold this over, where I have the complete chassis rail, I basically clamp down on several other tubes that have these fingers, so that they can just slide in to each other, and I don't have to think about anything. I can just weld it. Here I'm making some measurements to where some of the other tubes need to go, and then again I'm making these small inserts with a little bit of margin. Laser cutting is extremely precise, so a tenth or two, which allows material differences due to temperature, and then you have an extremely accurate product that you can just fold and insert pieces into. And sometimes you don't even have to weld it, or with just one or two spot welds you can then complete your entire construction, which is of course awesome. And yeah, that's one of the main advantages of laser cutting, and of course it takes quite a long time to engineer things like that, and to think about how a construction should be inserted into each other. But yeah, think about how much time it would take to manually cut this and then align it. As you can see, I'm putting in these slots in all different directions, so I can put them on the inside and at the top, and at the back side, at the bottom. It doesn't matter. I mean, the laser cutter has these grips, and it just rotates the profile to wherever you want to have the cuts, which is another big advantage. And yeah, you should really look up a video on how laser cutting works. It's truly amazing. And what's even more cool, especially with a chassis like this, where you have a lot of different profiles, you can use a laser cutter also to graph the numbers, or part numbers, or arrows, or for top, for example, into your steel. So when you receive your package, it could, for example, say part 1, part 2, or an arrow with this side up. You can just use the laser head to cut a very thin marking into the profile. And this is of course this is awesome, and it helps you with your assembly and your build. You can imagine that sometimes you have a lot of small profiles with completely similar shapes, and then being able to mark them with a number or an arrow, for example, is a tremendous help. What I did, there is a tool in SolidWorks called Flex, and what you can do with that is you can basically use two planes and an axis to tell the planes basically where a hinging point is, and then the program will use an axle to hinge a product. And as you can see, I made a pie cuts, and using the pie cuts we could actually fold the product at those pie cuts to get the actual end result. But the first one isn't that difficult and will go smoothly, but then the second one, your geometry and your axis change, so you have absolutely no idea what you're doing for the second fold. And that means that you just have to guess and estimate and try and get into the right area, and it's just time consuming and difficult. So if anybody has a better option for this, please let me know. Um, that's the funny thing about SolidWorks and any other 3D CAD file software. You work with what you got, what you know, and sometimes you need to find out something new, and that's what you try. But it's definitely not that I'm an expert or that I know the best way to do it. It's just this is what I found. This is what gave me the result I wanted. The only thing now is that I have a folded piece which has a completely different XYZ axle than the straight piece. So in the actual drawing, this is not really ideal. But in the end, what I wanted to achieve, I did achieve. I can put the straight piece on the drawing together with the folded piece, and it's in one part. Um, yeah. So finally, I managed it, but it was very very difficult. So here you can see the base chassis that I showed you before. This is basically the calculation model, and now I'm gonna show you the end result of the tube in its bended form, and how nicely it fits into the chassis. And also I'm going to give you a slight preview on how the rest of the chassis is developing, with some of the uprisers that come from the markings that I showed you that I made inside the tubes and on the top and on the sides, to allow the other profiles to be inserted into some very precise slots. And yeah, this basically means that it's starting to become an actual product, that is easy to install and to weld, and yeah, it's nice to design something knowing the capabilities of the technology, and that's something that I wanted to do with this project and also show you. And I hope you enjoy this. And in the second part of this video series, I will continue with the design of the chassis.